class, this is a section about circles, and we're going to go through the area of a circle and then area of some sectors. I'm going to kind of break down how the area of the circle formula came to be, and then I'll actually give it to you. So if you can remember back when we did circumference of a circle was 2 times pi times the radius to find the distance around. What this picture here is doing is saying that, like, pretend like we take that circle and we just split it into like lots of little slices. Or you could even like take each one of these and split them in half again. Or take each one and then split half of that. So hopefully you can envision that we have like lots of like little pieces. And then this picture kind of takes those little pieces and reflects the one, and you have these different reflections or rotations of each one. The length of that would be half the circumference, and the height of that would be the radius. So if I'm looking at like the area of this parallelogram, like what we looked at the other day, it would be half of the circumference times the radius, because that's the base times the height. And if I then take this formula here and plug that in for circumference, I have half of the circumference being 2 pi r times the radius. And then if I just simplify this, this would be pi times the radius squared. So this is the actual formula that we're going to remember. You don't necessarily need to remember how to get to this, but I did want to go through and just kind of illustrate that and show that to you. So here we go with the formula. Area of a circle, area equals pi times the radius squared. The way I remember learning this in high school is I knew this, and I knew circumference was 2 pi r, but sometimes I'd have to like think to myself like, wait, which one's which one's circumference and which one's area? And then I remembered that area is the one with square units. So if you can remember like those two different like kind of expressions, just 2 pi r and pi r squared, but have a hard time remembering which one's which, maybe that will help you also. When we look at this example here, there is part that's missing. We need to add in that this diameter is 72 inches. So please take a second and just add that in so that this makes sense when I read it. It says here, an outdoor accessory company manufactures circular covers for outdoor umbrellas. If the cover is 8 inches longer than the umbrella on each side, find the area of the cover in square inches. So this would be like the covers to where they have like the overhang on it. Maybe something you'd have like out on your patio that would cover like a patio table. I'm going to see if I can get this circle. Nope. So here we have this extra circle, and it says it's 8 inches longer on each side. So this would be an extra 8 inches, and this would be an extra 8 inches. The goal is to find the area. Before I can find area, I need to find what the radius is. And here, it doesn't give me the radius, but it does give me the diameter of this to be 72, or you could find the diameter of the whole thing. So you have some options with how you set this up. If I wanted to find the diameter of this whole circle, the diameter would be 88. Make sure you don't just add the 8 onto one side, but you add it onto both sides. So then that's going to make the radius 44. So area is pi times the radius squared. We usually get pretty big numbers for these. Don't be surprised by the big numbers. It's because we're squaring something. We're going to get something pretty large. I would not probably leave this one in exact form, but if you did, it'd be 1,936 pi square inches. I think it would make a lot more sense if we just went ahead and changed that to a decimal. So that would be about 6,082.1 if I'm rounding to the nearest tenth. and that would be square inches. Since it doesn't say, it technically wouldn't be wrong to leave it this way, but I think this answer makes more sense. The next thing we're going to do is look at sectors, and sectors are just portions of the circle. So I'm going to write some examples. Maybe you guys can think of some too and then share them with me later. For some reason I always think of like things like a piece of pie or a piece of pizza. If you've ever been to a track meet and you see the shot put area or the discus area, that's an example of a sector. You might hear somebody say you need to throw it in bounds or it needs to be within the sector. Those would be examples of sectors for that. We would want to find the area of the sector. This again is just kind of like the portion of the circle. And if I found the percent of the whole circle, that would be the angle over 360, and I multiplied that by the whole area, which would be pi times the radius squared. This would equal the area of the sector. Hopefully this looks very familiar to you. When we did length of an arc, it was basically the same thing, except instead of pi r squared, it was 2 pi r, because we were talking about like the percent of the circumference. Now we're just talking about the percent of the circle. So if you find the percent of the circle by dividing this interior angle here, that central angle, by 360, that would give you like the ratio of how much of the circle it is, and then multiply that by the whole part. For these, it's asking me to find the area of the shaded sector. I'm going to just use that formula for all three. For this first one, the angle is 53, and that's out of 360. I'm going to multiply that by the whole area of the whole circle, which would be pi times 4 squared. Just make sure you grab your calculator and you type this in. Make sure you know how to type it in correctly on your calculator. You should get that to be about, it says rounded to the nearest tenth, 7.4, and don't forget to include units on these. These would be square feet. For this next one, that is 148 out of 360 degrees. Multiply that by the whole area, which would be pi times 6 squared. So 148 divided by 360. Make sure you just grab your calculator, type this in. You should get that to be about 46.5, and that'll be square meters. For this last one, just be careful. They don't give you the actual angle here, but you could always find it. Just do 360 minus 65. This angle, or this arc, would be 295 degrees. So 295 over 360 times pi times the radius squared. Also, sometimes if they give you the diameter, just pay attention to that. Make sure you're answering the question that's being asked. So this one would be about 311.5, and that'll be square inches. You may have some like this where they give you the area of the sector and you need to write an equation and then solve for one of the missing pieces. Just use the formula and you should be able to, go through and do the algebra to do that. And this is a pretty quick section. We're moving right through. The last example here, it says the color wheel at the right is a tool that artists use to organize color schemes. I know on your paper it's just black and white. Just look at the colors here. It says if the diameter, pay attention to the fact that that's the diameter of the wheel, is 10 inches, and each of the 12 sections is congruent, find the approximate area covered by green hues. So when I'm looking at this, this would be 3/12 of the whole circle. So even though you don't necessarily know what that angle is, we don't need to know that angle. We could just know that that's 3/12 of the whole circle. The question here is asking, find the approximate area. This would be 90 degrees if you want to write that in. I'm just going to use that it's 3/12 of the whole area. So I'm going to multiply that by pi times 5 squared. Make sure that you figure out the radius before you just plug that 10 in there. The area would be approximately 19.6, and that'll be square inches. So we'll work on this in class, and let me know if you guys have any questions.